We're going to finish up chapter 3, talking about energy sources today. So this is a graph that's from a government website, but unfortunately it's converted into British thermal units, but it is about the United States Energy Information Administration, so it's been converted to units that we don't necessarily use. We focus more on watts, but it was the most recent one that I could find from a reliable source, and it provided the data that I needed to show y'all. So this is the U.S. energy consumption by energy source. So from 2017, so it's about 3 years old. You can see here that the top 3 uses are petroleum, which is 37%, natural gas, coal. So those 3 we're going to talk about as a group. Then there's nuclear electric power, which is 9%, and then the renewable energy sources are all kind of grouped together as 11%. Within the renewable source, we have hydroelectric, wood, biofuels, biomass, wind, solar, and geothermal. So those are all considered to be renewable. Everything else on the left is not renewable. So what is petroleum? Petroleum is oil that comes from oil-bearing rock. Essentially, it's kind of absorbed within the rock, and they have to break it apart and get the oil out. Petroleum and natural gas are usually found together. So natural gas like propane, methane, butane, they're lighter. The petroleum products are usually heavier ones, but it includes things like asphalt, things like Vaseline, candle wax, anything along that's kind of an oily product, your gasoline, your diesel fuel, your mineral oil, things like that. So these were formed from organic sediments, matter also that have settled out of bodies of water. So in a kind of a timeline, these would have been living objects that lived underwater, 300 to 400 million years ago, so a long time. Once they died, they kind of joined this orange layer you see here, plant and animal remains, and we're really focusing on these animal remains. They were covered up by a layer of sedimentary rock, which we'll talk about when we get to earth science. And then 50 to 100 million years ago, there would have been kind of more modern species of aquatic life that we're familiar with. And then eventually what happened is the entire body of water became a layer of sedimentary rock on top of what became oil and gas deposits. And then now what we do is we drill down to these oil and gas deposits, and we pump up oil from underneath, and we distribute all the way around, and that's where our petroleum and natural gas products come from. Of course, now we have things like offshore drilling rigs. It works very much the same way, except for instead of it being an entire layer of sedimentary rocks, it's over the ocean. But they're still drilling down into these deposits, very similar to the image you see here. Now, coal is another type of product which is going to form from the accumulation of plant materials that collected under special conditions. Okay, so because it was special conditions, it means it is limited. That's what makes it non-renewable. But this happened millions of years ago. So petroleum, coal, and natural gas are all classified as fossil fuels because they originate from plant and animal fossils, and they are non-renewable. So once we use them up, that is all we have, and we don't have any more to continue to use. So that does pose a problem because if you go back to our graph, when you have nearly 75% of your energy consumption each year dependent on something that is non-renewable, it means that eventually you're going to run into an energy crisis. Hence why we have all of these different types of renewable energy sources, because we're trying to be able to bridge that gap quickly. So moving water is a great example of a renewable source. Back when these hydroelectric dams were first started in about the 1960s, moving water accounted for about 40% of all of our U.S.'s energy. That's how much it produced. However, nowadays it only generates about 7% of the U.S.'s energy. Yes, our energy demand has gone up, but hydroelectric dams have not really kept up as far as in their ability to produce more energy as the demand has gone up, and that's because they're geographically limited. It must occur in an area where you have a body of water at a high elevation that can be retained with a wall like this, and then water flow down to a separate way. But the problem is that this is great for the people up here who need that water, but downstream, the effects of damming up a river, we now know that what this means is it changes the landscape. It prevents water from being in places where other people might live, putting them in a jeopardy situation with needing water. It also means plants and animals that need water don't necessarily have that. So we know that we're altering our landscape, and it's unalterable. Once we change the landscape, it's very difficult to recover that and have it go back to how it was before. So what it looks like, you have this a storage reservoir, the downstream outlet, you have the dam that's built up, and then as the water is going to pass through, it's spinning a turbine underwater, which then generates power, and that can be transmitted. Nuclear energy is another example of something that is non-renewable, but there is an advantage in that it does only take a small amount of a radioactive product to produce a lot of energy, and these reactions are very slow, and so we can take just a small amount and it can last us a long time, which is great, unlike oil and coal that runs out very quickly. But nuclear power plants are going to rely on nuclear energy to produce electricity. And it's a very complicated arrangement that we're not going to cover in depth. But you should know that they are very efficient, but a lot of safety risks are associated with the use. And so these are 3 examples of nuclear disasters that have happened in the last probably a little over 100 years. So this is 3 Mile Island, which is outside of New York in the United States, that had a nuclear meltdown in the early 1900s. The one you see here is probably the most famous, which is Chernobyl. And then the last one at the end, this is in Fukushima, Japan. And the meltdown in Fukushima happened just 2011, so about 9 years ago. And so this would have been in Ukraine, and this would have been in Japan. Okay? So for different reasons, all are different reasons, there was a nuclear meltdown that occurred at these 3 places. You're going to see some videos about Chernobyl, some links that you need to watch before you respond to the assignment this week, and so you'll see those on the place where you've got all your assignments listed. Energy sources for tomorrow. So like I said earlier, we are looking towards the future. How are we going to be able to bridge that 75% gap when the time comes? So alternative sources of energy are a major investment of research resources, meaning lots of people are studying it and lots of people are spending money on it, which is a great thing for research because money and people make research happen. So the main idea behind new energy sources is that they need to be renewable, efficient, and safe. So these are some examples of some renewable resources or renewable sources of energy, but we're really only going to talk about solar energy just quickly. So solar energy is used to describe a number of technologies that are directly or indirectly utilizing an alternative energy source. So they're using the sun. So some examples are solar cells, which you see here, wind energy, which these are turbines, and then biomass. And so the neat thing about solar cells is they can be put pretty much anywhere, the roof of your house, the roof of buildings, and they often put energy back on the grid. So people who have solar cells in their home will find that they produce enough of their energy to power their house and then provide back onto the grid, which is great. Solar cells are pretty expensive. They are only really useful in places that gets a lot of sun, which in the United States is most places. But they are subject to damage if you live in a place where there's hail, things like that. So there are some drawbacks to solar cell use. Now, wind energy, these are the turbines. They're very common west of Fort Worth, towards the plains in Lubbock, Big Spring, Midland, Odessa, out there. Places where it's very flat, not a lot of trees. So we don't see a whole lot of them here in East Texas, at least that I've ever seen. But the thing about the turbines is wind is a constant source in most places. It's really great out in the flat plains where the wind is always blowing. but each turn of the turbine produces a lot of energy. The thing about the turbines is people don't, for reasons that make sense, they're not the most scenic looking thing. When you're driving down the road, it does subtract from the beauty of the landscape when you've got an entire field of turbines. So there are a lot of people who are very against wind turbine use. The last one is biomass. Now, biomass is a big group of different things that could be included, but some of the things are like biodiesel, so taking oil, like used cooking oil, and converting it to biodiesel, very similar to diesel that you would get from the pump. And so taking something that's a waste product and producing it to something that is not a waste product is a very popular thing. Taking corn, the wasted products of agricultural production, producing corn and things like that, and turning into a fuel is also something where a lot of research time has been devoted. But the idea here is that there's lots of different types of alternative sources out there, but finding the best one is probably going to be the biggest challenge. So this ends